Hello, and welcome to the Skill Me Up Academy certification talk. Today we're going to go through an exam cram for Azure Fundamentals, which is the AZ 900 class. My name is Dwayne Natwick. I am an Azure MVP and a senior cloud training architect lead here at Opsagility. I author content and provide live and on-demand training for Opsagility and for the Skill Me Up Academy platform. I've served in the IT industry for many years and have multiple certifications within both the Azure and the Microsoft 365 role-based certifications. I am also a Microsoft certified trainer and a regional lead for that program, and you can find me on the social media links that are provided on this slide. So as this is an exam cram, this is a quick overview over the next 2 to 3 hours of all of the objective areas that make up the Azure Fundamentals exam. So we're going to go through pretty much everything that has to do with the exam. We'll give an exam overview. We're going to talk about cloud concepts at a high level, core Azure services, core solutions and management tools, general security and network security features and within the Azure environment. We're going to talk a little bit about identity, governance, privacy, and trust within Azure services to handle both Azure and hybrid cloud environments. And finally, we will talk about how to manage cost within Azure and the Microsoft service level agreements that go along with the Azure services. So let's set the groundwork here and talk about what makes up the Azure Fundamentals exam. And what's in it for you here is you take the AZ 900 exam, you will then obtain a certification exam from Microsoft for Azure Fundamentals. It's a fundamentals exam. If you're familiar with the Azure role-based exams that they went to a couple years ago, there are fundamentals exams, there are associate exams, and there are expert level exams. This gets you started on that fundamentals path in Azure. It gives you your first certification if that is where you are within your certification journey. The nice thing about the fundamentals exams that at the time of this talk, they do not expire. They are good. You don't have to do any renewals to them. Once you've gotten your fundamentals certification, you have that. Where with the associate and the expert exams, there is a recertification process that you go through for those. But it's a great first step, as I said. It gives you a good base knowledge around the entire Azure ecosystem, and we will go through many of those services here in this talk. There are 6 what are called exam objectives that are part of the Azure Fundamentals exam, and this is a little bit different than a few months ago. They actually updated this exam in November, where it used to be 4 objective areas. There are now 6. Some of them they just expanded and added some content around, particularly around the security and governance and cost management. Those were all somewhat in one objective previously. Now they're 3 of their own objectives, which is good because they're very important pieces, and a lot of services go in there. So they expanded those quite a bit. But we have our cloud concepts, our Azure services, our core solutions and management tools, the security module, identity governance, privacy and compliance, and then our cost management pieces and service level agreements. And as you can see, they are fairly, the weighting of these 6 areas are fairly consistent. When you see the weighting, you can see the amount of importance that's put on the particular area. Like I said, these are fairly consistent between 15 and 25 all across the board. But you can see that identity governance and privacy and compliance, as well as cloud concepts, make up a higher level than the other 4 areas. So you know you're going to get tested probably pretty heavy on those areas. So let's start on that first area of that is a highly weighted area, and that is cloud concepts. And this being a fundamentals course, it's important to understand these cloud concepts and to discuss the cloud and to understand at a base level where the cloud is coming from before we take that a step further and now talk about Azure services. So this module makes up the foundation of understanding the cloud terminology, and what goes into that, and what goes into the responsibility within the cloud, as we then move into the next module of core services. And what I like to talk about when we talk about the cloud is how we really got there. And it's important to just kind of visualize and understand from a standpoint of where we went, where we've come from. Back in the 70s and 80s, we had mainframes and supercomputers, which in this visual we really couldn't pick up. They were full room-based computers. They were large line of business applications that were running on them, and only accessible and utilized by large organizations and governments. I'm sorry. They were extremely expensive. IBM was at the forefront of many of these mainframes and supercomputers. And then we took that a step further and adapted. And in the late 80s, early 90s, we started to get to personal computers, and to then the client server type computing that became much more available then for small and medium businesses as well as enterprises. And we started seeing the email applications. Windows came to be in that time frame at a consumer level as well as a business level, to be able to have access then to our email, both at home and at work. And we started seeing all the networking take place. From there, then we moved into virtualization now, where we're taking a computer and we're breaking that out and utilizing that as a host for multiple operating systems to run on it, which now it helped us out from a standpoint where we're no longer investing in a ton of hardware. We are now utilizing virtualization software such as VMware or OpenStack, and we're now decreasing our hardware utilization, and we're now creating these virtual servers that can be handled through a single management plane. In around 2010 or so, maybe a little bit before that, now we started getting into hyperscalers, and we started talking about cloud computing, AWS being at the forefront there, and then Microsoft not far behind. 2 companies that were building their own virtual environments and virtual data and data centers for virtualization, that they decided now they're going to offer to subscribers for essentially rental of those computers and rental of those hosts to run our virtual machines. And we also saw around that time Office 365 capabilities come in to that software as a service type environment. So that brings us to today, and really around those cloud concepts. And what we're going to do in the next slide now is now that we've set the groundwork here and how we got to this virtualized world, we're going to now talk about what the capabilities and uses are in there and within this virtualized world and the cloud for our different use cases and different types of services that are based within these cloud environments. So when we talk about cloud, we talk about the as a service type environment. And first and foremost, we see the infrastructure as a service, or IaaS, come into light. It's really that emulation to the virtualization of the most part of your on-premises type environment, like we were talking about, where we had our host and we were building virtual machines on top of that host. Infrastructure as a service does just that. Microsoft Azure provides you with that host, and you now build your virtual machines on that host. And what we see it utilized for within the environment is that lift and shift type mentality, where we're going to take the image of our virtual machine that is in our own data centers, and we're going to move that into the cloud so that we no longer have to make the investment in that hardware to host that virtual machine. The next step logically then is to platform as a service, or to PaaS services. And PaaS services are pre-built services within the Azure environment or within the cloud environment that then provide you with the ability to host your applications. We'll talk more about the specific services around that, but what it does is it now takes away the need for the overhead of managing an operating system and handling an operating system on top of that, on those virtual machines. The host and the operating system and all of that protection in terms of backup and anti-malware and antivirus, all of that protection and all of those pieces of that virtual machine now, and that compute service now is provided by the cloud provider, and you as the consumer are now only responsible for what you're putting on that resource. And within that Windows or Linux machine, now you don't have to handle those operating systems. You're strictly writing applications, and it's very helpful for developers then to utilize these services because they don't have the overhead and don't want to have to worry about update management and updates on and patches on servers and updates of software and for the operating system. And that in that regard, they want to strictly rely on the application and the APIs of that application. Or if you're a database administrator, you want to work on that database. You don't want to be patching an operating system. You don't want to be patching and upgrading from an old version of SQL Server software, for example, to the latest version that's supported. You want to not rely on that and not worry about that. And that's what PaaS services do for you. And the final one then is software as a service. And then software as a service is where you go online, you buy an access license or a user license. If you're a business, you buy a group of user licenses to a software, and you then just need to give your users access to it, provide any kind of protection in terms of sharing rights to data within there, and you're ready to go. Office 365 is a prime example of what a software as a service is. Gmail Suite, Salesforce.com, those are all software as a service type deliveries where you're no longer handling anything in terms of the application. The application is being pre-built and delivered to you, the user, and you are just logging in, and you have access to all of the software and everything that it runs on. And so, as we talked about before, and we'll go through these again quickly just for understanding's sake, is we have our infrastructure as a service. And as I said, this is lift and shift type. This is a full access to an operating system, and it is similar. The similarity to your own data center is that it runs those operating systems and can really, if you're running Hyper-V within your data center, you can very easily just take that Hyper-V image and put it on an operating system within the Azure environment. Same thing, you can do the same thing with a VMware virtual machine and convert that to be utilized within the Azure infrastructure and within a cloud infrastructure in most cases for both Windows as well as virtual machines. An example of this is exactly that. Virtual machines or virtual machine scale sets are part of that lift and shift and that utilization. So we're now buying then those virtual machines and that infrastructure as a service rather than having to invest in those host machines to run those virtual machines or the software for running those virtual machines. And as we were saying with platform services, again, compute services now are managed by Microsoft or the cloud provider. There is limited or no access to operating systems at this point, so you don't have to do patching or upgrades to those operating systems. It's used for modernized apps as well as databases, such as SQL database, Kubernetes services, Cosmos DB, as well as app services as some examples within the Azure environment. Serverless computing is becoming more of one of those as a service offerings. So it's important to understand the difference between those as well as versus PaaS and SaaS services. It kind of falls in between there a little bit, where we are looking at and utilizing a PaaS service, but we are having no compute access. It's really functions as a service. We're running code to create workflows within our environment. And Azure Functions, Logic Apps, and Cognitive Service can fall into those within the Azure environment. And we'll talk more about each of these services as we go through this talk and when we're talking about the actual core services and what they are. But I'm just giving examples as we go through here as well. Software as a service, these are ready to go purchased services. No interaction or limited interaction besides just maybe some configuration of software. What we need to do as a consumer is protect user identity and take into account how data protection and retention is going to work in there. And a prime Microsoft example of that is Microsoft or Office 365 services. We've talked about each of these as a service areas within a cloud environment, but how does it really affect how you need to perform your daily duties and work within those environments and protect those environments? And that's what shared responsibility model really discusses here. Within a traditional on-premises data center, you see we have full management and ownership over the entire stack from the networking and all the physical components, the building and all of that, all the way up to the application. As we move across and look at the services that come as part of infrastructure as a service, platform as a service, and software as a service, we now give some of that responsibility of management over to the cloud provider with infrastructure as a service. And you can see as we move across, we're giving more and more of that responsibility to the cloud provider, where we are with infrastructure as a service, we're still handling and managing middleware, operating system, antivirus, all of those things. But as we move into platform as a service, the cloud provider takes over that piece, and we get the software as a service, and there's very little management responsibility we now have for the application. Like I said, we handle the identities of users and how we protect data within here, but everything else is all encapsulated within the application that's being delivered as a software as a service. A good way to kind of visualize this in a way that we all can understand is pizza as a service. I believe probably everybody listening to this has had pizza in their lifetime and have gone through different ways of obtaining and consuming that pizza. And pizza as a service really shows you how the different ways, depending on how you are getting that pizza and obtaining it, where that shared responsibility is in the realm of the as a service levels. Traditional on-premises type data centers can be looked at just like you're making your pizza at home, where you have all the ingredients, you're putting them all together, you're putting them in your oven, you're serving them to your family, and everybody's consuming it that way. Infrastructure as a service is very similar to if you go pick up a pizza at the supermarket. DiGiorno would be an example. That has the dough, the sauce, the cheese, the toppings all on that pizza. All we have to do then is we're providing the oven, we're providing the table, we're providing the soda that is being consumed by your family at that point. But we did not provide any of the physical the physical ingredients and everything were already put together for us. Platform as a service would be like we're getting a pizza delivered to us, or where we're even getting a carry-out pizza. It's all cooked and ready to go. We just serve it when we get home or when it gets delivered to our front door. And then software as a service would be very similar to just going to the restaurant and they're handing you your beverage, they're handing you your pizza, and all you're doing then is consuming that. Would be very similar to what we would think of as software as a service. So you can utilize this pizza as a service scenario, across all of those infrastructure, all those as a service type components, to kind of get an idea and to really just kind of consume how they would work and how they would differ from each other. As part of those responsibilities, we think of like responsibility zones, and this goes along the lines of how it would work from a security standpoint and how we would protect our environment, where we would always have data governance and rights management within our environments. We have client input points and users that we would need to manage, and then we would have the account and access management that we would define. Depending on the model, we have varying areas here in the middle in terms of identity and directory infrastructure, application, network controls, operating system, depending on whether it's an infrastructure or PaaS or SaaS type service. And then finally, we transfer everything to the cloud as far as everything physical is transferred to the cloud provider and within that bottom zone versus an on-prem type environment. So just another way to look at it and another way to think of it in terms of zones and how everything changes there. So as we get finished with this particular section of the cloud concepts, and we do have some more concepts to talk about, it's important to kind of stop and take a pause and to understand how these go together and do a quick knowledge check. So the question here is, which cloud service type requires the customer to manage the underlying hypervisor platform for their cloud deployments? So what are we going to do within this for this question? So I'll pause for a moment, let everybody think about it that's listening online to this before we get to the answer. The answer here is none of the above. And the reason for that is the key piece of this question is the hypervisor platform. In none of these as a service services, as a service deliveries, do we have any access to the hypervisor. The hypervisor is the host, just really another term really for the host system and the essentially, if you're familiar with virtualization, like the VMware vCenter type environment, is that hypervisor platform. And we don't have access in any case through any of these services. Now, if it said, where would we manage the underlying operating system for their cloud deployments, that would be infrastructure as a service. So keep in mind, the way the questions asked and what they're asking there. But when we're talking hypervisor, we're talking what's on the physical host, and we have no access to that physical host. Second question here is which cloud service type would best match the following situation? So we have several web applications have been developed within the organization. The web applications allow users to enter details in a form, and those details are then emailed to a shared mailbox. The form is accessible from the internet and can be accessed anonymously. So what cloud service type are we talking about within this scenario for the web application? And we'll pause momentarily and give you time to think about the answer here. And in this answer, we're talking about a platform as a service. So we're not talking specific services at this point. We're talking about different platform solutions. And so the web application can be hosted then in a platform service through hosted websites. The email service will probably be sent through a SaaS solution as part of this. So it's kind of a two-tier scenario here where we're talking about both the platform of the web application and the email part of the SaaS solution, which might be like Microsoft 365. Next, we're going to talk about the different cloud models. So we just talked about the services that are underlying those as a service models of IaaS, PaaS, and SaaS. So let's talk now about the cloud models. And we start with the public model, and so we have then private cloud, and we have hybrid cloud. Private cloud is exactly what that is private cloud. That's your on-premises data center where you own your equipment. We have our public cloud, which is Microsoft Azure, Microsoft services, if they're SaaS services for 365 services, AWS, Google Cloud. All of those fall into that public cloud realm. And then hybrid cloud is a combination of both, which typically most enterprises are going to utilize that hybrid cloud infrastructure. They don't have everything within a private cloud. They don't have everything within a public cloud. They're using what they need out of both to get the job done, to have their business running, and to utilize the benefits of the public cloud, but also sometimes they might have applications that they require a certain level of security for the within the that only the private cloud is going to provide when they have full control at the physical and hypervisor type level. As we move into the public cloud, we need to ask why. Why would we utilize the public cloud? And really, the biggest reason here is we're looking at on demand and consumption-based subscription models. And those help us from a standpoint where we don't need to make any upfront capital investment of upfront cost of hardware to get services created and to develop applications within a network infrastructure. And it provides additional automation as well as geographic diversity, where we can, if we need to expand beyond our current footprint, we don't need to purchase more real estate in terms of a data center. We can utilize the Azure environment and utilize their global infrastructure to create services and to turn on services within other geographies. And again, reduced hardware maintenance. We've talked about this a little bit already in multiple in the other conversations that we were having, especially with platform services and SaaS services. We don't need to maintain hardware within any of those, because the hardware is maintained by Microsoft within all of those. That cloud responsibility and that responsibility bucket of the physical hardware all falls on the cloud provider. And then from a security standpoint, Microsoft has built in many security features that might not be cost effective for you to implement in your own environment. Making that investment might be very costly, but Microsoft has those services where you can easily turn them on as needed for additional security controls within your environment. Where would we use private cloud? Would be where we have a pre-existing environment. Obviously, we have already legacy applications that we can't modernize them for a public cloud type environment. We might have different security level requirements that we need to adhere to, as well as data sovereignty of where that data needs to be physically located, and have that control based on regulatory compliance or local industry compliances. regulatory certifications and things of that nature all fall into, what we may need to utilize a private cloud for. Another piece to think of here is we've already made a large investment in new equipment, and it might not make sense right now to, while this equipment hasn't depreciated and while it's still viable, to just abandon it completely. We might just continue to utilize that and look at how we can then maybe modernize those applications going forward to utilize cloud resources, public cloud resources, once that equipment has been depreciated within our infrastructure. And then the hybrid cloud takes that where we can now utilize the best of both worlds. We can utilize our existing investments and equipment that hasn't depreciated. We meet our regulatory requirements. We can meet regulatory requirements for certain applications and data that need to stay in our private cloud, but those that fall outside of those lines, we can take out into the public cloud and maybe make some and benefit in some of those economies of scale within the public cloud environment to save some money and to take advantage of those benefits. We have legacy environments. Again, we might need to utilize the private cloud for those legacy environments. The migration capabilities, we would utilize the automation, the migration of the two for hybrid cloud, and we can then just ultimately utilize that environment and utilize the best of both worlds and begin then to do a staged type migration from the private cloud to the public cloud through that hybrid environment as well, utilizing cloud infrastructure for archiving of data and things of that nature as we no longer need to have network storage utilized for data that we're not accessing on a regular basis and things of that nature. So here we come to another knowledge check to think about here. And in this scenario, we're talking about which cloud deployment model best fits this scenario. And here we're looking at a server is needed to process data for a short-term project. The organization does not have the hardware that meets the performance requirements, and the project starts in a few days, and the server is not needed once that project is complete. So in this scenario, what are we thinking about in terms of which type of cloud would be best suited for meeting the need here for this short-term project? And I'll pause for a moment. And in this scenario, we're talking about a public cloud type environment. We can utilize a server, turn on a virtual machine within Azure, create that server utilizing the consumption-based pay-as-you-go, and then remove that resource as we finish with that project. A PaaS service might also be a possible candidate here to eliminate the complete need for a server entirely. If we're turning on a database, we could utilize a PaaS service rather than turning on a virtual machine as well. But in both those scenarios, the public cloud environment is the direction that you want to go for handling this particular short-term project. So as we talk about the cloud services and where we would want to utilize those public cloud services, it's important to understand the benefits and how we're going to look at our cloud and look at what we're going to utilize. And there's multiple terms that you need to understand, such as high availability, scalability, elasticity, agility, fault tolerance, disaster recovery. All of those are driving factors to utilize cloud services because that's all built into the public cloud. And what goes along with that is then understanding how economies of scale work within there. the economies of scale within public cloud provide for a difference in capital expense versus operating expense, and how we can then utilize those modernized data centers and those applications for our environments, and what Microsoft does to build these large regional databases with resiliency of power and networking and heating and ventilation and air conditioning. All of this is a large investment that most organizations can't afford on their own, so they utilize these environments and can then build on those environments for for high levels of security, high levels of growth, and the geographic expansion of their resources. And when we talk about CapEx and OpEx, it's the difference between the two is that if we're running in a CapEx type environment where we are investing in that equipment, we're buying that hardware, we're now shifting within the cloud environment and the public cloud to an operating expense where it's a pay-as-you-go, it's a monthly bill, it's like your cable bill, your internet bill. It now becomes then you have an infrastructure, you have now your cloud bill that is part of that, part of what you're already paying for in terms of your electricity and your facilities and your internet access. You're now paying for your infrastructure on a month-to-month type basis, and it just hits your balance sheet in a different way. Then we have and as we were saying, that operating expense then is that consumption-based model based on what you're utilizing and what capacity you need, then can expand and extend over time without any upfront commitment. You don't rather than in a CapEx model, you have to purchase equipment that's necessary for the growth that you're expecting, and that growth may or may not come to fruition. It may change. You may redirect where you're growing, and you may never hit that capacity on that particular piece of hardware, or you may go beyond that capacity, and then you have to invest in more hardware to meet that capacity. The consumption-based model and the operating expense of the public cloud allows you to take that, and you can move at your own pace, and you never have to worry about moving beyond what the capabilities are, because there are unlimited possibilities within the public cloud. So let's talk about some of these and do another quick knowledge check here. The capability of a system to be enlarged to accommodate a growing amount of work is best described by what? And so this one is a little tough, because some of these terms kind of run together a little bit. But as we look and think about what we're talking about here of enlarging to accommodate growing work, what are we talking about here? And we're talking about scalability. We're talking about the ability for a resource now to grow, whether we're going to scale in or out, which means we're going to add resources or decrease resources to scale, or whether we're going to scale up or down, which means we're going to add a higher level of performance to a particular service. That's what we're talking about here, is we're scaling our service, whether we might be adding virtual machines to scale out, or we might be scaling up by adding additional resources in terms of CPU and memory to an existing resource to scale that up and to add more growth to that. As we talked about, in terms of as we grow and as we have more demand within our organization, we may need to take that a step further. And in general terms here in the next knowledge check, when an organization moves to the cloud, will it see a reduction in CapEx, OpEx, or both when it moves to the cloud? What would be the answer that we would think about here? And in some cases, it would be both. I have a question here in terms of where this would lie, but for the most part, immediately you're going to see a capex decrease realized, because you're going to reduce the amount of investment for and need for on-premises type equipment. You're eliminating as you eliminate and migrate workloads. As things depreciate, you're no longer you eliminate that depreciation, and you're no longer making an additional capital investment to those resources. For operating expense, you may see some management cost reduction in operating expenses moving to the cloud. This is one that there probably could be some debate about, because you do still have some management tasks and things that you need to take into account if you move to the public cloud. But if you build in some built-in automation, and you also utilize platform-based services and SaaS-based services rather than infrastructure as a service type services, this could be the case, that you're now eliminating some of those operating expenses in terms of your operations team and your management team, and some of that management overhead. So hopefully now you've gotten yourself a good foundation of understanding what IaaS, PaaS, and SaaS are, as well as public, private, and hybrid cloud, and some of the features and benefits of that, as we talked about moving to the cloud and that CapEx to OpEx model. The next section here we're going to go into now is going to be the core Azure services that now fit into those parts and those pieces of IaaS, PaaS, and SaaS, and we'll talk about those, and I'll highlight where they fall in as we go through. So first thing we're going to talk about is the architectural components that go into there before we actually get into the services. First and foremost is understanding how the Azure infrastructure works, and Microsoft has regions within their geographies within the countries. A region is not necessarily a country; it's a set of data centers within that country, and you can see on this map. It's probably not the easiest to see that Microsoft data centers and regions are spread all over the world, and within those regions, they pair certain regions with high-speed backbones and like-for-like services that are offered within there, so that you can build some resiliency as you're building your environment and creating your infrastructure and architecting within the Azure environment. So it's important to note and to review some of those region pairs as it goes with the Azure 900 exam. You don't need to necessarily know what region pairs with what region. Just understand that there is a pairing of regions within within geographies. For example, West US and East US pair. I think South Central and North Central pair. East and West Europe and pair. So they stay within those geographies to keep the data sovereignty of those services. Within that governing body, but keep that in mind of how those work. And then we have our geographies, which is the actual countries that go along, that each of these are in and encapsulated in. Then we take that a step further to our availability zones, and availability zones are a different concept where we're now talking about the actual regions and the data centers that are in those regions. Each data center region has 2 to 3 data center buildings within there, and that each one of those is considered an availability zone. And you can then utilize each of those to build a level of resiliency just within that region, and not necessarily even in that, by pairing certain regions if you don't want to pay for duplicating equipment over a geographic area. You can do it just within that region as well. And you can do that for many reasons. If you're worried about power going out, each of these have different power, cooling, and networking components to them coming from different directions. So you don't have to worry about a backhoe going and taking out all of your facilities. It's only going to take out potentially one of them, and the others will stay up and running if you're utilizing an availability zone. We have availability sets then. That's a subset within an availability zone or within a specific data center where you can now build those availability sets on different fault domains and different update domains, where we are making sure on a specific rack that we don't have our virtual machines go bad if that rack goes down. The update domains make sure that the virtual machines don't go down at once because they're on the same host. We can utilize availability sets with fault domains and update domains within that availability zone, or we can do it just within that specific data center building. And then we have our resource groups, which exactly what it is, very easy to think of what it is as a resource group as a group of resources. And it's a way to compartmentalize maybe an application or our storage or a specific service within a resource group. And it makes it easy, especially if it's an application that is a project-based application that's a short-term resource, to put that all in one resource group. And then when you're finished with that and no longer need it, you can very easily just delete that entire resource group and clean all of those resources out of your environment and no longer get charged for those resources. And then Azure Resource Manager is the underlying component for managing and for maintaining all of our resources within the Azure environment. We have multiple ways to do that. We can access the Azure Resource Manager through the Azure portal. We can utilize the SDKs for Azure PowerShell and Azure CLI to automate scripts and automate deployments of resources within the Azure, as well as REST API clients can be utilized as well. Most notably, most utilized is Azure Portal, as well as from a graphical user interface, and then PowerShell and CLI is more of a from a command line type deployment utilization. REST clients, we can connect with other third-party services such as Terraform to also utilize for managing and deploying our services within the Azure environment. So let's now do another knowledge check real quick. And the first thing we're going to talk about here is what is the term that best describes the feature that is made up of one or more data centers equipped with independent power, cooling, and networking, and set up to be an isolation boundary so if one goes down, the other continues to work, and typically connected to each other through very fast private fiber optic networks. And if we look at what the selections are here, the best selection here within this is the availability zone, which is made up of those multiple data centers within a specific region. So they made sure that they didn't get to the point where we're talking about paired regions or anything like that. If that was in there, probably would have added a little bit of confusion there. But here we're talking about those availability zones, those three potential data centers within a region that are utilizing separate facilities to access your equipment and to provide facilities to your equipment that you can then put your services in those different and have those replicated in those different availability zones and utilize those. So here is, as we go into and talk about our services within Azure, we have multiple services that we can talk about. And this is kind of a periodic table of Microsoft Azure services here, and we can talk about each of these within the environment where we have our platform services, which we have our compute services in here for remote applications and service fabric, our web and mobile, and which we have our app services and web app services. We have different development services, analytics and IoT, data, which is our SQL, our different database management type services, our storage accounts. We have storage queues and integration. We have over here, we have different hybrid operations that we can utilize. So all of these components within here make up, the platform services. We have our, and down at the bottom, we have our key primary infrastructure services. So we look at here, our virtual machines and containers are our primary compute services. Our storage is made up by our storage accounts with blob container storage, Azure Files, or premium storage and managed storage, managed disks for our virtual machines. We have all of our networking components down here, virtual networks, load balancers, DNS, express route, traffic manager, VPN gateway, application gateway. All of these services are important to know and important to understand. The key components within here, as we're thinking about the exam, are to understand the key compute of virtual machines and virtual machine scale sets, and understand how those work. Our storage, which is our storage accounts with blobs and files, and then our key components and networking to understand is our virtual network is our main component of networking to think about, and then we have other ways to manage traffic such as load balancers and DNS and express route and those things. In terms of platform services, as we're thinking about the exam, think about understanding app services and logic apps and how those can be utilized for web development and app development. Our different database services of SQL database, SQL Data Warehouse, which is now known as Synapse Analytics, are your main things to know around databases. There's also Cosmos DB and MySQL as a service, and Postgres DB as a service as well within Azure. Our analytics and IoT, just understanding the different pieces here with the machine. We have machine learning and cognitive services within here, event hubs and stream analytics. Those are all big data type services as well. And then on the security side, we have the portal. We have Azure Active Directory, which we'll talk a little bit more about. And when we get into identity services, we'll get into more of these. Excuse me, Key Vault and things of that. We'll talk more about the security and management a little bit here in a moment. Azure AD Connect for hybrid operations, and this connects that Azure Active Directory to our on-premises Active Directory environment. We have backup and site recovery services for backup and replication services for business continuity and resiliency. Privileged identity management as a separate layer of just-in-time privileges for our administrators. Import-export services are utilized for the migration of data, of large amounts of data from your on-premises environment to the Azure environment, and the other way as well, where you where you send a disk to Azure and an encrypted disk, and they can then load those large amounts of data within the Azure environment. So let's stop and pause for a knowledge check again around what we just discussed and what we were thinking about in terms of those services. So suppose you have an existing application running local on your own server, and you need additional capacity but prefer to move to Azure instead of buying or upgrading the on-premises hardware. Which compute option would you likely give you the quickest route to getting your application running in Azure? So you're running on your own server locally and you want to move to Azure. What is your quickest capability to move to the Azure environment? And this would be to move to a virtual machine. And this goes right along with what we were talking about in terms of infrastructure as a service and that lift and shift type usage of Azure, where we're taking that virtual machine on premises, our on premises hardware, and we are moving it to the cloud environment. Which service offers a distributed network of servers that can efficiently deliver web content to users that focus on minimized latency? And we didn't talk about this in detail when we were talking about all the services, and it's not something we talk about a whole lot within the exam either, but it's good to know. And what you can think about here is we're talking about a scenario very similar to like a Netflix delivering video content to around the world, and what that would utilize would be a content delivery network. And what a content delivery network is a distributed network of servers that caches that information and provides that to the local user with very minimal latency. And it's very helpful, like Netflix uses would be a good example of a service that utilizes a CDN network. Video on demand is a prime example, prime use case for a content delivery network. So we went through pretty quickly all of the compute services in terms of that chart. It's important to understand, like I said, the key things to understand is what the virtual network components and the VNet is, what a virtual machine is, what a SQL database service is, and what application services are. And before we get into some of these management tools, let's look at how some of these can work and go together here. So within our environment, as we start to build our services within Azure, we have multiple things that we can do here. The key thing and the key pieces here that we've talked about are our resource group. So within our resource group, if I choose a resource group and go into this particular resource group here, I can look that I've got a group of resources down within my environment that you can look at and review. Key things within here that I have that are really part of the building blocks of your architecture are having a virtual network. Having your virtual network in here, having a storage account potentially is good, but first and foremost within any resource group and with any usage of resource is you're going to have a virtual network. Without a virtual network, we have no way to communicate. We have no way for other networks to communicate to us. So we would have to have a virtual network. Within here, we then also have different services within this particular environment. I have my storage account. I have a virtual machine, so I can utilize my virtual machines in here. I can put application on that virtual machine. I have a network interface that goes with that virtual machine, as well as the disks that go with that virtual machine. If I were to go back to my resource groups if I look at this resource group, I might have different resources within here as well. Again, though, key thing to notice is I have in here also a virtual network. I've added a level of security within here with a firewall. I have some monitoring tools turned on, such as application insights, and we'll talk about some of the tools, but we won't go too deep into that. Again, I have a storage account in here as well. Both of them, I had a key vault for my keys and my secrets. So I have all of those services in there. When you create a resource group, resource groups can be created without a virtual network. You want to build those virtual networks and build a your virtual network and what is on that virtual network based on what where they need to communicate, what services need to communicate with which. Then we would do that inside our resource group. If we were to go in here and also create now a virtual machine, if I go to add a Windows server within here, I could very easily within my Windows server, it is within my resource group. I could create a new resource group or put it in a different resource group. I would give it a name, determine what size my virtual machine needs to be based on what the cost might be within here. And if I were to step through here, what disks need to be on it, what management what managed disks, both my operating system disks as well as my managed disks for storing data within my environment. Again, I can put this on an existing network or I can create a new network right in here. I can determine how I'm going to manage that, whether I'm going to monitor my operating system within this virtual machine. I can put extensions in here if I have to put certain malware protection or antivirus protection on this server. I can do that here. And then I can just create my server, and I can create a server, a virtual network, and a resource group all within this. It's not the best practice necessarily to go ahead and do that from the standpoint of your virtual network and the proper configuration and planning of your virtual network to do it with a virtual machine. We would like to actually create and plan out our resource groups and our virtual networks and the resources within that environment as from an architectural standpoint. And we'll talk a little bit later. We'll bring up and talk about the cloud architecture, the cloud adoption framework a little bit and how that works. But those are all ways that we need to plan and think about our environment as we build them out. So how would we, what are some of the solutions and management tools that we also need to think about in the environment? And these are, very similar again to thinking about the analytics tools and the IoT here, our data and what data services we have within here, our web and mobile services. All of those platform services within our environment now become different solutions within the environment that we've now moved up from infrastructure services now to those platform services and what we need to utilize within those environments to continually, to modernize our applications and to take a higher level of advantage to around our usage of public cloud services, taking those advantages of lowering the need of management overhead within our organization and our company to continue to evolve and to refactor the use of how we are utilizing our compute resources and our environment for our users. And so as we talk about that and we think about take another knowledge check here of we have multiple web properties that a customer can reach. We would like to create a common set of code that each of them can use to create a lead in your customer database. Which Azure app service would you use? So we would like to use a common set of code to create a lead in your customer database. What service app would we use? And within this one, we would use an API app. So we have a common set of code over multiple platforms. We now need to create some level of API to allow those clients then to utilize that HTTPS and HTTP protocol for that functionality. Here, what is not considered an Azure serverless computing service within here? So which one of these is not considered serverless within these four selections? Azure Machine Learning technically is not serverless. This is a container-based service. Machine learning works on compute services under a container, typically such as Docker. So it is not considered machine learning. The other ones, Azure Functions, Logic Apps, and Event Grid, all fit within that serverless computing piece. So if we look into our computing and into this list here, we do have event hubs and machine learning all in the same place. So it's hard to kind of think about what we have here, but these are, if you remember from our as a service components, we did have a little bit around, some of those the cognitive services within that whole Azure, the Azure Cognitive Services kind of fit into that serverless. But when we're talking about machine learning services, machine learning services require a high level of compute. So that's where why we're still utilizing compute services for machine learning. They're very similar to how a large database is going to be handling and transforming and reviewing reviewing data within our environment. Azure Machine Learning is going to do the same thing. So when we talk about management tools, we're going to talk first about the Azure portal, which I showed a few minutes ago when we were going through and we were looking at how a resource group and our environment, how we can set up our network and all of our components within there. So the portal is, like I said, before, a graphical user interface for the management of resources within Azure. PowerShell, though, is more of a module-based command type utilization where you have multiple services. All the services have some level of naming and within the PowerShell environment, and it's a scripting language that you can utilize to deploy, to update, and to change resources within the environment. We have the Azure CLI, then a command line type scripting language that you may be familiar with, from utilizing Linux and you can utilize across Windows, Linux, and Mac operating systems. The commands are very similar, and if you are comfortable with command line type languages, you might prefer to utilize the Azure CLI. And then finally, the Cloud Shell kind of brings together both of those types of management tools of PowerShell and Azure CLI, where you can utilize PowerShell right from the portal, or you can use Bash for the CLI right within the portal as well. And it's very quick and easy for simple type queries and simple type deployments, where you can simply click on Cloud Shell. It then creates a storage account that it's going to authenticate to within the Azure environment. You're already authenticated, rather than utilizing multiple modules and things of that nature, or utilizing other tools such as Visual Studio to author and deploy your code. You can do that directly within Cloud Shell. So it's just another tool within the environment, within the actual Azure portal, to be able to utilize within your browser, where you can still utilize Azure CLI or Azure PowerShell, utilizing like a Visual Studio, or utilizing even just PowerShell directly on your Windows machine. So let's talk now a little bit about security and network security. We talked about virtual networks a bit, so let's talk about the security pieces and components of things. And as we talk about security, it's important to understand the types of threats and what we're trying to protect against. And what we're trying to protect against generally are both potential internal threats as well as external threats. And those threats are, we have potential threats in terms of loss due to, vulnerabilities inside of our network, and then external threats are those bad actors and that might come in to our environment. They may have social engineered a password and they're getting into your environment. The internal threats and the typical internal threats we're looking at are, shadow IT, vulnerabilities and patching, different elevated privileges we might have, developer backdoors, and different perimeter threats that might cause cause some level of exposure created by misconfiguration or misuse of information within our user environment. And then we have a full list of external threats, and OWASP has a very large top 10 list that they provide. Some of those are like denial of service attacks, brute force attacks, vulnerability exploits, identity spoofing, injection attacks, and those type of things that are direct attacks on your information by external people that are trying to cause harm to your business in most cases. And really what is going to happen within here is then potential threats to our data, where we might cause some level of financial information being lost, exposed, or compromised that we do not want to happen within our environment. So to protect ourselves against that, we think of now protecting at a defense in depth type of strategy. And the big part here is what we're thinking about and how we're going to protect ourselves. The first and foremost is the physical security. Now, within a public cloud environment, the physical security is no longer our responsibility. It is now the responsibility of our cloud provider, in this case Microsoft, to provide that physical security layer. But then it starts to become our responsibility once we get to that identity and access piece. And we need to now think about, from a access control standpoint, making sure that nobody has those elevated privileges. Make sure that if they do have elevated privileges, that they expire or that they're reviewed periodically. Our perimeter security, having proper firewalls in place, having proper rules for our ports so we aren't leaving openings for bad actors to come into our environment. Having proper network security and how we're protecting our virtual networks with proper segmentation to sensitive information and sensitive resources. Having hardening our operating systems, or having our secrets and our certificates in a managed key vault type environment where we have more control over it and avoid any kind of exposure to those keys and how we access our computers, back to even perimeter security and the port rules, making sure we're only allowing access to our resources when access is needed, and having those rules turned off that are allowing that access when somebody isn't needing that access. Proper API security and API management in place for our applications, and encrypting and classifying our data in our databases for making sure our information is safe, and masking that data if we do have sensitive data is another important piece here, and encrypting all of our data both at rest, which is by default in most cases in most services within the Azure environment, as well as encryption in transit and in use in some cases as well. And then monitoring all of this all along the defense chain to make sure that nobody is exploiting or for getting through any of these levels of defense. So when we talk about security within the Azure environment, we talk about some shifts in responsibility, and some of those shifts are that you have some responsibility over this, but also that Azure takes on some of this responsibility. It's important to understand where those threats are and how we can manage that from an identity standpoint, an encryption standpoint, as well as a networking standpoint. And we talked about the different availability zone, different responsibility zones back when we were talking about the shared responsibility, and it's very similar when we're talking about security responsibility and security responsibility zones, where we are always going to retain the responsibility of our data governance and rights management, our endpoints, and our account and access management. That is always going to be our responsibility, whether it's on premises, in an IaaS, a PaaS, or a SaaS type environment. And within the cloud provider environment, when we move to a cloud provider, the physical pieces always stay in the provider zone. The middle area, though, it's important to note and important to understand where the responsibility lies and how it's different, whether we're going IaaS, PaaS, or SaaS. And you can see based on the gray to the blue is what is our responsibility. And IaaS, it's all our responsibility from operating system to identity and directory infrastructure. When we go to PaaS, the operating system, and SaaS, the operating system is no longer our responsibility. But with PaaS, there's a certain level of sharing of responsibility here. The platform services generally have some level of identity and directory infrastructure, application security, and network controls that are in place for securing that platform, as a whole. But there are advanced services and advanced controls that you can turn on to give you a higher level of control based on what your needs are as an organization. Same thing with SaaS. You can turn on different identity and directory controls and directory policies even within like Office 365 for conditional access policies or privileged access management and things of that nature. So it's important to take all that into account and look at all of that. And we'll talk about some services that can help you with that here later on in a different mod when we're talking through a different objective area, but these are all things to keep into account and to understand where that level of responsibility lies. And Security Center is one of those ways to to manage and maintain those pieces and those parts within the environment. And we look at that and we look at what we can do in terms of our roles for infrastructure and identity, for multi-factor authentication, monitoring, update management, policies, analytics, advanced threat protection, which has been renamed Defender in a lot of areas within the environment. All of these areas and components fall into the Security Center infrastructure and can monitor this information for you and provide recommendations for how you are going to handle and protect these zones that you're responsible for, or even where the shared responsibility lies. And if we go back into the portal here, I can show everybody how helpful Security Center can be. Security Center can provide you here with a level of recommendations for your subscription that can tell you how you can better protect your organization and what you need to do to protect your organization and where you have proper protections in place versus making some adjustments to your protections to increase that level of protection within your organization. And Security Center has two different flavors. One is a basic free level that everybody gets when they create an Azure subscription, and then there's a Defender or standard subscription that is a pay for that gives you even some additional regulatory compliance capabilities as well. But what we're looking at really is what those recommendations are, what they are across different services, and what we need to do to help make those services more effective and have those controls in place, those higher level of controls that are going to help us to protect our resources and maintain our defense in depth strategy for our user environment and for our data. Azure Sentinel is another piece to think about and to understand in terms of security controls and security services, where this is a cloud-based SIM for security and information event management, and it will integrate with many other controls and data sources, provides artificial intelligence, threat intelligence feeds, and extensive compliance reporting within the environment, along with forensic capabilities for investigation, and allows you then to investigate, assign certain incidents to different user environments, and then respond to those threats accordingly. As we talk about security and protecting our data, we want to protect our how we are securing that data with different encryption keys or with secrets or even our certificates for proper encryption in transit within our websites. And Azure Key Vault provides us with that service within the Azure environment. What Azure Key Vault does is it provides for users of Azure a way of having that separation of duties for our management of our secrets and keys, rather than those being managed directly in the service by Azure. You can turn on Key Vault and make your storage accounts or your database accounts or your encryption of your virtual machines those keys all managed by Azure Key Vault. And again, it keeps that separation of duties. And there's two different flavors to Azure Key Vault. There's a basic service where it allows you to do that all within the Azure environment. Or if you have a HSM system on premises, you can use the premium service and utilize a synchronization of keys from your on-premises HSM to the Azure environment as well. And it provides then secure access and permissions and the ability to then log the access to resources, and the ability for not exposing keys to developers or administrators or even to users that are applications that are utilizing other applications to connect and authenticate, so that you don't expose your keys to within those environments. And you can then utilize all of those services and rotate those keys without having to go in and rewrite your code. So Azure Key Vault's a very helpful service, especially for certificates for your websites. You can utilize Azure Key Vault to manage the life cycle of those resources as well. Azure dedicated hosts we'll hit on quickly. It's not anything super in depth in terms of the Azure environment, but it's important to understand that there are capabilities within Azure to create almost a private network of your own, utilizing these dedicated hosts where you're no longer sharing the host compute services with other tenants. You're having a much more secure, isolated hardware environment at the physical level with a dedicated host. You are now reserving that host for your resources, for all your compute resources. So therefore you're isolated and have more control over the maintenance of it and the updates, as well as, again, a level of security that it's isolated from other tenants to a certain degree as well, where you're not sharing compute resources with other tenants. It does come at a high price, though, so keep that in mind. It's good for those services that you might have in terms of like an SAP service, that you have high levels of compute needs and you want that compute to be all on one single host as well. Let's talk about network security layers. So very similar to defense in depth, we can take it and blow it out a step further from a networking standpoint and think of our network perimeter, and there's an inside and an outside perimeter. And what services then are provided within that network for protecting both of those perimeters. You know, what's our outside perimeter, what's our inside perimeter as we think about that. And the first of that outside perimeter is the Azure firewall. The Azure firewall provides that first level of defense when somebody from the outside is coming into your Azure environment. And what Azure firewall does is, if you're familiar with your network and have your own firewall within you generally have an appliance within your environment. What Azure firewall is really that firewall as a service. It's a stateful next-gen firewall, provides a level of centralized governance with high availability and unlimited scaling. So rather than having an appliance that has a certain level of bandwidth and a level of capability, we can definitely scale out our Azure firewall service for additional needs. It provides, again, that level of traffic filtering and policy-driven rules across our virtual networks and subscriptions. So we have, just like we would an on-premises type environment, we can now manage our services at a layer 3 to layer 7 capacity and capability to route our traffic from the web or from our on-premises environments and route it to the proper services within the Azure environment that particular request needs. So our website might go to users from our website might go to a certain virtual machine set when our internal users coming from on-premises or coming from their work from home environment might go to another set. Microsoft provides a distributed denial of service protection by default within its environment. They do not you do not have to turn this on or do anything with it to utilize it. It's there for the most part because Microsoft does not want any type of denial of service attack to hit their network, because it's going to not only affect you as a single tenant, it's going to affect all their tenants. So they're protecting against any kind of denial of service attack by default at no additional cost. It's there when you turn on your Azure subscription. But if you do want to have additional insight into what's taking place within that environment and what's being what potential attacks are taking place, there is a standard subscription to DDoS protection that you can upgrade to and get more telemetry data around what's happening on the network around this service, and that can then be fed into Azure Sentinel as a SIEM or any other SIEM, so that you can evaluate potential attacks and what might be taking place. But if you don't have the capacity to do that, to review that information, or don't have the manpower to do it, you can just leave the basic service on. Know that there is a level of DDoS protection that you do have. Network security groups are also another piece where we are, working on stateful rules that allow for, and allow or deny traffic, very similar to what you would see in a firewall. You can set some rules even before you turn a firewall on when you're doing development to allow or block a certain level of traffic. There are levels of default rules for allowing and denying both inbound and outbound traffic. The lower the priority number, the higher the priority is for that rule, and what and how it is identified and addressed is based on the lower number working its way up. So you can, when you look at the network security groups, you can see that there are multiple rules there are 3 rules in both inbound and outbound rules that are by default. Our inbound rules are deny all inbound, allow any load balancer traffic, and virtual network to virtual network. The difference between inbound and outbound default rules is outbound, instead of the load balancer rule there's one that is allowing outbound internet traffic so that you can get to the internet when you're within the Azure network. So those are the default ones, and then you can build up from there. You know, in terms of blocking RDP traffic or things of that nature, you can allow, you know, here an RDP jump box. You've got some different things within here. Application gateway, we'll talk about different capabilities within application gateway, and traffic management ultimately is really what we're talking about here, where we, you know, application gateway is that application layer service where we can now utilize this for managing our web traffic at the application level, put in different web application firewall services for avoiding SQL injection, cross-site scripting, all the OWASP top 10, as we talked about when we were talking about our external threats, and provides then that front end for our HTTP traffic. And it also integrates with other traffic management services such as Azure Traffic Manager, Azure Load Balancer. It can also be deployed then into any VNet and utilized from that standpoint as well. So let's take a quick knowledge check now. Gone through quite a few slides, so let's take a step back here and see how we're doing here in terms of understanding of knowledge within the environment. So which of the following is not a method of protecting internet-facing services from network attacks? So we have Azure DDoS protection, we have application gateway or web access firewall, Azure disk encryption, and Azure firewall. Which one is not a way to protect internet-facing traffic? And if we take a moment here and think about it, it would be Azure disk encryption. Disk encryption, we're protecting the actual disks, and we are encrypting the information on those disks. We are not doing nothing with Azure disk encryption in terms of protecting internet traffic, or internet traffic's not having anything to do at all. This is at a virtual machine level, and what is happening with the virtual machine disks and how they're being encrypted and protected. Azure DDoS does protect internet-facing traffic from a denial of service attack. Application gateway protects that internet-facing traffic from certain types of attacks like cross-site scripting and SQL injection. And Azure Firewall is our cloud-native firewall that can have those customized rules that is inspecting that traffic from the internet. So all 3 of those are internet traffic security services within the Azure environment. So let's go into our identity governance policy and trust objective area within the Azure Fundamentals exam. So first and foremost, it's important to understand what are identity services. And within Azure, we have Azure Active Directory, which is the comprehensive identity and management service within Azure that is a cloud-based service for identity that provides a robust set of capabilities to manage your users and your groups and secure access to your applications such as Office 365, as well as those Microsoft non-SaaS applications like Azure, for example. And when we talk about Azure Active Directory, we need to think about our understanding what makes up somebody's identity and how they are accessing services within within Azure and within the Microsoft ecosystem. And to do that, you have authentication and you have authorization. Authentication is verifying who you are, or what that device is, or what that service is. And once you've verified who you are and who you claim to be, you then have the authorization level of what you can now perform and what you can now do. Or we'll talk about it in a term of what your role is and what you're authorized to access within that environment. And Microsoft has then the different identities within there of what they can authenticate and authorize access to. And within Azure Active Directory, we talk about our applications, we talk about our groups, and we talk about our resources. And the identities can manage all of these in terms of what they have access to. You can register apps to within Azure Active Directory for access to certain resources, or have users access those apps. We can create groups of users and give them roles and give them capabilities and authorizations within the Azure Active Directory environment. And we can also do that with resources and with service principals to say that this resource needs to be authorized to access this resource. Typically, a lot of times that might be an app service that is authorized to access a database, or a virtual machine that's authorized to access a specific database for, say, from a web-based application that needs to access inventory, but it probably won't have access to sales information, or access to our the company financial information. It might feed information to that, or the database might feed information to that. It might have access also to a customer database, so that customers can log in and their information's there, so that they can create a shopping cart and check out easily. From there, we have our multi-factor authentication, which is another level of identity control and access. And part of that authentication piece, not the authorization side of it, but the authentication side, is to provide then another layer of that verification, and that is generally in the form of something something you possess, or something you are. Something is a password or a PIN number. Something you possess is a code that was emailed to you, or texted to you, or that you're accessing through the Authenticator app on your smartphone. Something you are is your biometrics, such as facial recognition or fingerprint recognition, are those somethings you are. And as we take that a step further and think about what we have now in terms of we're authorizing various devices, users, groups, applications to certain data and to applications as well. How are we looking at that identity protection and protecting ourselves from any kind of exposure in that identity protection? That's what conditional access does. Conditional access will take a specific signal from a device, a user, location, a risk level, a particular application, and trigger some level of additional verification of access, and then provide, based on that, what they're going to give them access to and authorize. So you're going to look at this signal and this condition being met, that's going to trigger potentially allowing access or requiring an additional level of verification, such as multi-factor authentication, or changing your password before you're allowed access, or you can block access completely. And it helps to protect against suspect locations, potential devices that might not be compliant, trying to access your network and get access to your data. So when we're talking about governance, we talk about different tools for governance, and some of those tools for governance are what we're doing to monitor and manage our subscription, and we might do that in terms of how who has access to those subscriptions and what we're managing in terms of whether it's pay as you go or reservations of services within the Azure environment. We have our role-based access control where we're now providing the authorization to resources based on specifying different roles to who has access to those. We can set different policies in place within Azure Policy to govern our resources from a security standpoint or a cost standpoint or an operation standpoint from whether we're going to put encryption on virtual machines to whether we're going to allow virtual machines to be created in certain regions and locations and what SKUs of virtual machines might be allowed to be able to control that particular costs, and that high cost machines aren't allowed in our particular environment. And we can do that at a subscription or a resource group level, which helps us also to govern sovereignty of our data as well, where we can put specific location parameters on specific resource groups based on where they're located and what the governmental requirements are. And then also as a subset within policies is initiatives, and initiatives are really a group of policies. So we group a whole bunch of policies together that are best practices of that organization. There's multiple standards and compliance-based policies or initiatives as well. That's a group of policies that you can utilize to audit your resources against regulatory compliance, such as HIPAA or PCI DSS or NIST, or create an initiative for GDPR for protecting privacy and data within and complying with those standards and those regulatory standards as well. We can create management groups to protect to set up specific cost governance and build back areas within our environment. We also have the capability within Azure Advisor provides us with different layers and different recommendations that might help us in many areas. And we can go into the Azure portal and take a look here at Azure Advisor and see what that can do from a recommendation standpoint. And you can see it provides 5 levels of advisory here in terms of cost, security, reliability, and operational excellence and performance. You can see that I don't have any recommendations right now for operational excellence or performance, but I do have some recommendations on cost, security, and reliability. One of those recommendations actually could save me, that recommendation in cost could save me almost $1,700 a year. So we can see within here what we have in terms of high impact, medium impact, and low impact. I have quite a few recommendations here in security, as you may have seen when we went into Azure Security Center. Very similar to the recommendations you see in Advisor for security, as you would see within Azure Security Center. But this is just another place that you can kind of govern the capabilities within your environment and adhering to certain best practices. So let's do another knowledge check here, and this is a true-false type question, and we're going to talk about this question pertains to Azure Policy, and Azure Policy is used to control per user permissions in Azure and control the types of resources that users can deploy. So does Azure Policy control per user permissions in Azure and the types of resources that it can deploy? This one is false. It does not focus particularly on users. It focuses on the resources and the actions against particular resources and resource groups in your subscription, and how that and what the restrictions are in terms of where those resources are provisioned and things of that nature. So it's a tough wording of the question because it throws that deploy piece in there. But really what we're talking about here is we're talking about role-based access control. And we're focusing on the actions that the users can perform and what they can do in terms of their different roles. And there are some main built-in roles in terms of contributor, reader, and owner that we see within the within role-based access control, where the owner can not only create and remove resources and adjust resources, but they can also delegate to other users a level of rights and role-based access control as well. Contributor can create resources within a particular resource group or subscription or a service, but they cannot delegate those rights. And then there's the reader, which can then just review the rights within there. And then there's the user administrator, where the user administrator can delegate rights as well and create users and things of that nature. But those are some things to think about here in terms of what we're talking about in when we're talking about the differences between policies and role-based access control. Policies is at the resource level, and what and the rules for creating those resources and within certain criterias, but it's not the user-based level. We're talking user deployment, user capabilities, and what they can deploy. We're talking role-based access control. So let's talk about some different monitoring requirements here, and what is needed in terms of when we're thinking about monitoring within the Azure environment. We're thinking about now what we're trying to do in terms of reading and watching our resources. And there are 3 different levels that we want to talk about. And first and foremost is that visibility, which is what visibility do we have? What's the big picture that are we looking at all of our metrics in a multi-dimensional format from every are we looking at it in every direction? Are we putting in place real-time alerts and notifications? And are we watching from different dashboards the health and availability of our resources and monitoring those on a regular basis? And you can move multiple tiles and tables into the dashboard of the Azure dashboard and create different dashboards for different visibilities as well, or look at this within Azure Monitor. Can be utilized for this. We looked at a dashboard of Azure Security Center. We have dashboards within Azure Sentinel. All of those ways are to have visibility into all of these metrics, and having those turned on is important as well within our services to take a look and to continue to read and to turn on those services to be able to gather that information as well. From there, we look at insights and how now, once we have the visibility and we have those dashboards, what are we gleaning from those, and what insights are we getting to find and fix problems? And we can utilize different services such as log analytics and Custo queries within log analytics, Azure Sentinel again, Azure Security Center, to find and fix those problems, fix those controls, look at those recommendations and make the adjustments as needed. And we can also utilize automated actions and remediations to those as well, where we can take alerts and notifications, and we can take those alerts, and when certain triggers and conditions are met, we can trigger an Azure function or a logic app or a webhook or some sort of automation to an automation runbook, and trigger that automation to take some level of action to remediate those issues as well. Analytics and machine learning can allow us to also utilize that information and find anomalies and continue to review that information and continue to adjust how we are going to handle that going forward as machine learning begins to understand more about why that's taking place. And then we can, from there, take that information and take that analysis and those analytics and that machine learning and what we've done in terms of increasing our abilities to optimize and to learn and to continue to create a level of high performance and insight to build that continuous improvement and that continuous integration that goes along with different integrations with DevOps tools to monitor those workflows and make sure that we are optimizing how we are taking and utilizing our resources within the environment, both from an Azure standpoint as well as a hybrid standpoint as well, because many of these same monitoring tools we can utilize components of by putting agents on our other hybrid resources that can feed into the same ecosystem within Azure as well to run all of this information and to optimize our entire network, not just our Azure environment. So let's take another knowledge check here quick and look at this question, another true and false question, where with infrastructure as a service, you're responsible for the maintenance and patching of physical operating system hosts in Azure. So we're going back and we're shifting gears a little bit and asking a question back from our first module or our first objective area that we were talking about. So just seeing if you're staying with us here and remembering what we talked about a little while ago, is this question true or false, that you are responsible for maintenance and patching of physical operating system hosts in Azure? This is actually another false one. This is a tricky question again. The key word here is hosts and physical. If we took patching of operating system in Azure, this would be a true statement, but the fact that we're saying physical hosts is, again, a false statement. Microsoft is in charge of maintaining the physical infrastructure, and it's important to remember that, and that includes the data center, the physical network, and the physical hosts of your virtual machines and all other Azure resources. So anytime you see physical and you see host, keep that in mind, that is not your responsibility as a consumer. So some different other tools for governance as we went through and talked about some of the first level areas of governance. We did not talk about resource locks so much. We did hit on some of these. Apologize, this is actually a duplicate slide. So we did talk about subscription, role-based access control, policies and initiatives. I did not hit on resource locks, so we can hit on resource locks here quickly, where here every resource within the Azure environment has a resource lock. So I could go into my resource group here and very easily go under settings to locks, and there are two different locks that are available within a resource, and that is a read-only lock as well as a do not delete lock. So having that do not delete lock on, setting it the delete lock is that you cannot delete that resource. Read-only lock means that you cannot make any changes to that resource, including this resource group. If I turned on a read-only lock, I can't add any additional resources within this resource group either, nor can I delete any of them. So that's what resource locks are and how they can govern. if you have a production environment that you don't want any changes to be made to, you can certainly do that within here. But as we go through, let's talk a little bit more about role-based access control. We hit on it a little bit on that when we were talking about governance within the environment. But role-based access control does exactly that. It takes the users and groups, and we can then assign them roles and what they are authorized to do within the environment. And that is, and as I said, that's the owner, the contributor, the reader, or the user access roles are your built-in roles. Those are your primary level roles, and then you can get very granular with those roles where they are all the way down to the resource level of a virtual machine level or a storage account. So you can get very granular in terms of separation of duties within your organization utilizing role-based access control. Keep in mind that access is inherited from the parent resources. So if somebody is a contributor at the resource group level, they're a contributor to all the resources below that as well. So it's important to start to really create your role-based access control. If you are doing that separation of duty, to give them the roles at the resource level rather than the higher level of a resource group or a subscription, because they're going to then have a higher level of role than they might need for their daily duties. And then our resource locks here, we talked about those and showed those briefly, where there are the read only and the do not delete, which is or the delete lock, which is a cannot delete, which authorizes them to not delete those resources. And the locks then again are inherited by the child resources in this case, rather than the parent resource. It's the other way around. It's a child resource. So at the level of that resource that you set that lock, it's then utilized. Like I said, if I did a resource group lock, those resources are locked within that entire resource group. Tags are utilized for governing based from a billing scenario or ownership scenario of specific resources. So you can put tags in place and say, hey, this is a production environment and it's being utilized, for web services or SQL services. You can say that it is procurement cost center or human resources or IT, so that way you can then enforce those. You can enforce certain tags by policy, and then you can also run reports on those tags based on where their where their cost center is. So you could run a cost center report and export that to a CSV file and see what the costs are, and you can bill those back to the budgets of the specific departments if that's the way that your organization wants to run. It can be utilized as well for specifics for just understanding what applications are being, what resources are being utilized for a specific application. Like in this case, we have the workload of a web or a workload of SQL. We could say that we're, saying the application is for our web application. We can say this SQL database is for that web application as well. So there's multiple ways that you can do the tags. They're pretty flexible. One of the best practices around utilizing tags is to not have any more than, I think the rule of thumb is not any more than 15 tags within your environment, or it just becomes too hard to manage within and keep straight within your environment. We have multiple ways and multiple pieces of compliance, and we showed that a little bit within the Azure Security Center. With the key thing around compliance to think about is that that you can have within your organization multiple compliance requirements and multiple industry compliance that you need to adhere to. Within the environment, you have the ability to adhere to, say, NIST requirements or GDPR or ISO IEC 27001. Those are all all important within within your organization, and might be requirements. With you might have NIST requirements if you're with your offices in the United States. If you're in Europe, you might have GDPR requirements. You might have ISO 27001 requirements across the globe, and you need to adhere to all of those. And Azure can help you get to those compliance levels faster through certain capabilities. Azure Security Center is one of those capabilities that can help get you there by utilizing the compliance piece of Azure Security Center. And here you can see like ISO 27001 and PCI compliance right in here. And we can see where we are and audit very easily within our environment, what controls we might need to put in place for maintaining that compliance. And it might give us a short track to passing our audit and to maintaining our certification for that particular level of compliance, and avoiding certain potential fines that might take place for not being compliant. So Azure can help you with that. They have hundreds of different compliance attestations that they can that their data centers comply to, and then they also can provide you with controls that you can put in place to help get you as an organization to those levels as well. For, like I said, GDPR, there's FedRAMP, policies and policy initiatives. Policies and initiatives can help you get there also. If I were to go into policy, there are multiple initiatives that have to do with some of these. So if you have to go into FedRAMP, or let's say HIPAA High Trust, we can come down to find an initiative for HIPAA High Trust, and we can then put this initiative in place and audit our resources based on maintaining our healthcare organization's requirements to the HIPAA and High Trust in the United States, avoiding again any potential regulatory fines and sanctions that we might have to our environment. So let's go to another knowledge check here. What would you use if you want to avoid a resource in Azure from being modified or deleted? So what did we talk about that would do that? And if you remember correctly, this was a resource lock where we can set that to do not delete, or technically in the Azure portal, we set it to delete, which is a kind of a misconception there, or we can set it to read only for to avoid any kind of modification to those resources. All right. Now we are going to talk about some cost management and service level agreements within Azure. And this is actually the final objective of the Azure Fundamentals course. Subscriptions are those organize the access to the cloud services and resources there at the security. They provide the access at the and security level for what you're going to pay for and what your costs are. You're going to get billed at your subscription level. And then we have our accounts, which then are those, the account administrator is generally your billing owner, and then your subscriptions sit under those accounts. So you might have an account in terms of your enterprise agreement, and you might have then different organizational units and subscriptions within there. I have my particular account administrator login to my account. If I go in, I have different directories and different subscriptions under there as well. True or false? An Azure subscription may only have one account owner. True or false? That is true. There is really only one account owner for a subscription, but an account owner can own multiple subscriptions. And this is a little bit different than a global administrator. This is just really the account owner the ownership of that account and who that goes back to in terms of paying the bills. But you could have multiple administrators that can then work under that subscription and work in that account, but there really is only one specific account owner. As we plan and work through our Azure services now, we need to, how are we going to plan our environment? And these are identifying the different subscription types and how we're now going to, how we need to know how we're going to meter our resources. So we're thinking now about at a cost level how we're going to manage things within our environment. And there are different subscription types to keep into account and to understand. There's the enterprise subscription, which is usually for large enterprises where they create and have an agreement for a negotiated amount of spend that they're going to utilize. Microsoft's moved a little bit away from this from an Azure standpoint. It's been typically utilized for a long time within Microsoft for software agreements and for what they're going to consume in terms of Office licensing and server licensing on their machines, and Windows licensing. All of these go into those enterprise agreements, and they've typically over the past few years, or when they would allow you to put a certain level of Azure consumption in there. They're moving away from that a little bit for organizations that haven't utilized that particular Azure consumption piece of their enterprise agreement, and they've moved to having separate agreements for their Azure spend and their Azure commitments if necessary and if need be. They also have Web Direct, where you're purchasing directly through the website. And the way that a lot of companies are utilizing their cloud spend these days is utilizing, a cloud solution provider or CSP, where now they're going to a partner organization, and it might be the same partner organization that they might be utilizing for some level of management or development purposes, and they're purchasing then that Azure spend, and that is being billed then on a monthly basis to the organization. And the flexibility there is that rather than Web Direct, where you're really giving a credit card and getting billed to a credit card monthly, or an enterprise agreement where you're paying, making a commitment and paying up front annually for your spending, with a CSP, you are now doing this this is now a monthly invoice basis with that CSP and a purchasing agreement with them. You need to understand within the Azure environment the different billing types and the different billing ways different resources are deployed depending on what type of service they are. And the key things around what's billed within Azure are paying for the compute resources that you're utilizing, the storage capacity that you're utilizing, and then we're talking about data transfer rates and data between resources or between networks, as well as data transfer out of the environment. And those data transfers from Azure to from your location and from your users to Azure can be utilized from a standpoint of any and thought of from a standpoint that you're not getting charged for anything that you're sending into Azure, but you are getting metered based on what is being transferred out. And that is where you might see costs increase depending on whether you're bringing out a large amount of data and transferring a large amount of data. That's some ways to understand your costs. But your key is compute, and really where costs tend to get out of control within the Azure environment is the amount of storage that's going into the environment now, especially as you build more monitoring capabilities and are logging more activity and metrics and activity logs and metrics within the Azure environment. You're now storing all of that within the Azure environment, so that could definitely start to increase. So having good lifecycle management in your storage accounts is going to be very key. And here are some different ways now to manage cost within the Azure environment. And if you have those enterprise agreements, you do have an enterprise agreement portal. For most of us, we're going to utilize our Azure portal to manage our costs as our frontline management. Resource tagging, as we mentioned before, putting tags on our resources for our different cost centers. Azure Advisor recommendations. As you saw, I was told by Azure Advisor I could save $1,700 a year by doing something that I didn't review. I'll have to go back and look at that to see what's going to save me money. Setting certain spending limits. You have the capability as the account owner to set spending limits for particular resources or for particular subscriptions that they are only, and once they go over that, there's an alert that takes place, and then they need to ask for additional money. Consumption, billing, and enterprise reporting APIs, different services to and cost management services such as Cloudin, which Microsoft bought a couple years ago to utilize for your cost management services. There's many other cost management tools that you can utilize. Something else that's not mentioned on this slide is utilizing reserved instances for cost management and maintaining, decreasing your costs. As we talk about support plans, and we want to understand, what the types of support plans are within Azure. It's important to understand what the differences are between what you get for free versus what you pay for within the Azure environment. You have, with all accounts, you do have billing and subscription support. You have access to all the product and services documentation. Even without an account, you can access all of that through Microsoft Docs. That's all available. You can get self-help online. Again, Microsoft Docs has a whole bunch of self-help documentation. You can utilize the technical community forums and things of that nature. Azure Advisor recommendations, as I said, Service Health Dashboard and the Health API. Azure Service Health is where you can view potential outages that are within the Azure ecosystem that are affecting all tenants, not just yours. So if you're wondering why you can't log in while into your resources, or why this group of virtual machines in East US are out, you could look at Service Health and see that there might be an outage in that region and that's causing an issue, or an outage in that particular service that's causing an outage, and it'll give you a potential time that, potential amount of time that it's going to be out at that point. You can also then, there are also paid support plans where it allows you to have access to Azure support engineers. You get additional guidance in troubleshooting, architectural support, operational support for service renewals and reporting, and web-based training seminars. So with paid support plans, and sometimes you get these things as well if you're utilizing a cloud service provider for your Azure consumption as well. They might provide some of these to you directly as well. So those are some things to keep into account. From a standpoint of understanding some of these services and some of the paid support plans, you do have the standard support plan, which allows access 24/7 to those support engineers, and you have the professional direct service, which also provides that, and also provides a level of business critical support that is going to provide a quicker response time as well. So standard support really is not going to it is going to be a more of a get 24/7 support, but it might take a few hours for them to get back to. But there is a critical business that allows less than an hour of response time. If you have Premier support, you get additional support with less than 15-minute type response time. So the key things to understand around, you have your premium support, which is 15-minute response time. Professional direct gives you the ability to escalate priority-based issues. And the standard-based support is your first level of support that's going to give you 24/7 type access to support engineers in terms of the paid support plans. If you have a free account, you're not going to get that direct access to an engineer, and it's going to be kind of best effort, and you might be waiting for for 24 hours before somebody gets back to you. In certain cases, if it's not a high priority outage type scenario. So let's take a knowledge check here, and this goes right along what we were just talking about. So your organization relies on Azure services for hosting a critical application. You need 24/7 support. Which of the following support plans is the most economical option that still provides you with the 24/7 support? And as I said, standard is your first tier that provides you with that standard support of 24/7. So standard, Pro, and Premier all provide you with 24/7 support. It's just the big difference there is the level of quickness to escalation that you get on the other two tiers of Pro and Premium that provide a little bit quicker access to support engineers without them determining that things need to be escalated. You can determine that I need to escalate this, that it's critical, but we still get 24/7 type support on standard type plans. Service level agreements, then, as we talk about service plans and we talk about service health and outages, potential outages and things of that nature, we now start talking about service level agreements. And one of the key things when we're moving into a public cloud environment is that we now have a certain level of commitment within Microsoft for uptime and connectivity and performance, and how that performance is going to be handled, and what level of performance Microsoft's going to commit to. It defines then the guarantees in that availability of those services, and has certain policies within a service level agreement of what you might be able to ask Microsoft for in terms of service credits to your service. Each service within Microsoft has its own independent service level agreement. So you can go directly to the URL on the bottom of the slide, or just go into your web browser and search on Microsoft Azure service level agreements, and it will return back a website that's going to have all the services listed. You can click on those services and see what that service level agreement is. Some of those have special configurations for those requirements. For example, virtual machines require have a 99.9 level of service level agreement for a single virtual machine. If you have a scale set with 2 virtual machines, it takes it to a 99.95. So keep that in mind when you're thinking about how you're configuring it. Same thing with certain things around like Cosmos. Cosmos DB isn't a good example, like a storage account, and having storage account in local redundant versus geo redundant storage, things of that nature. You need to, if you feel that Microsoft has not adhered to their service level agreement, it is your responsibility to notify Microsoft that they have not adhered to it and provide what the criteria is for it. Microsoft doesn't just give you the credits across all of their customers. The customers need to initiate that support ticket to say, hey, you had me out for 3 hours today, 3 hours this month, and that's beyond the service level agreement for that month. And if any service level agreement is changed within the Microsoft environment, Microsoft is required to let you know 90 days prior to that change taking place that SLA is changing. Composite SLAs are a little bit different. So this is taking two services and is putting together and saying, okay, you're utilizing these services together, and these then multiply, these percentages multiply together to create the composite SLA. So keep that in mind, especially when you're thinking about web applications and Azure Active Directory and SQL database services, that they have different SLAs that actually combined create a lower SLA than the lowest SLA, just because of the way that you multiply percentages together. It's not something super major to keep into account, but just understand that you do have to multiply those together if they're being utilized together. So, true or false question: Azure SLAs are defined by the service tier of the product as below: basic, standard, and premium. So this goes along. This is interesting from a standpoint of thinking of different service tiers that are provided for SLAs. And if we remember what we just talked about with SLAs, this is going to be false, because this is each service. What they kind of combined, what was kind of combined in this question was thinking of support tiers or something like that, and response to a support tier. Each service has an SLA, so it doesn't matter whether you are utilizing a SQL database that is a basic SQL database, a standard SQL database, or a premium SQL database. The SLA for the SQL database is going to be the same. Lifecycle management is now what we're talking about in terms of new services coming online within the Azure environment. And we talk about service lifecycle in terms of 4 different areas within that lifecycle: planning and development, preview, general availability, and retirement. From a standpoint of planning and development and retirement, doesn't really concern us so much. What we really want to understand is preview and general availability. There are 2 types of preview. There's private preview and there's public preview. The important thing around private preview is that's reserved for certain top tier partners of Microsoft's. They get to see services in private preview while it's still really in that beta or that alpha type phase of planning and development. They get to poke around at that type of service and play with that service, generally because they've been really a key partner for that particular service. Public preview is when everybody has access to it. It's up on the site, and you can utilize that resource just like you do any other resource. Key thing around public preview, though, is there's no service level agreement when you're in public preview. So it's best effort there. You might have some failures in that service because it is still in preview. It's still being tested within the environment. But what Microsoft wants is more customers to test it as well and provide feedback as they go through. And then we have general availability, which is when everybody has it available and it adheres to the service level agreement of that service as defined within Microsoft's documentation. When a service comes to a close and comes to an end, then it's retired. But usually, when you're working with your services within the environment, you're working with most of those services then as general availability. Key thing to remember and take away from this slide, though, is when a service is in preview, it does not have an SLA. When it's in general availability, it does have an SLA. So, at what stage of the Azure service lifecycle should you consider an Azure service in production? So, where would you think of that? And I would say it's in general availability, because this is when it has that service level agreement and it has its capabilities at its full extent. It's been authorized by Microsoft. It now has been fully vetted out, and Microsoft is standing behind it. So as we finish up things here, the important thing to think about here around preparing for your certification is that Microsoft, the Microsoft services and Microsoft exams will provide you with a good base knowledge of that particular exam level. This being Azure Fundamentals, it is a very broad and all-encompassing type exam. So important to go back and review each of those services, especially the core services of compute and storage and networking and databases, and understand what those are and how those would be used. The Azure Fundamentals exam is a pretty straightforward type exam, where you're going to be given pretty typical questions like we went through in our knowledge checks. Pretty straightforward. You're not going to get a whole lot of scenario-based questions, but you might get a few of those as well. But they're going to be, again, fairly straightforward. Thank you very much for paying attention to my talk today. We here at Skill Me Up Academy provide the help and assistance for you to prepare for your certification with instructor-led training, as well as on-demand labs and learning paths that are based on and directed to the Microsoft Learn content. And we also provide a lot of assistance through our services with our CSMs to help build a plan for you through what you want to do in terms of your certification and taking your certification to the next level. After you get to fundamentals, where you want to go from there, feel free to reach out on our virtual conference manager platform to ask, what's recommended. I've passed AZ 900. Where do I go from here? And just utilizing those real-time labs will be very helpful to you from a standpoint of knowing how and what takes place within these environments. It's not super important in terms of Azure Fundamentals, but it does help you understand how the resources go together. And as you move to the associate and the expert level exams, you can definitely find and gather more information out of that as well. And our real-time labs allow you to do that without bearing any costs and doing anything that might cause a production issue within your own environments as well. So use our, Skill Me Up Academy real-time labs are very helpful to you. And so to wrap things up, we went through a lot in terms of our objectives of the Azure Fundamentals exam. I gave you an overview of the exam, and then we went through all of the core cloud concepts, the core Azure services, solutions, management tools, security features, protection, governance, policy, trust, all of those things, cost management, service level agreements. We covered a lot of information here in the last 2.5 hours. I recommend that you go look at the Microsoft Learn content and our labs that we have in our virtual conference manager. As you prepare for Azure Fundamentals, review Microsoft Docs for the different services so that you understand them completely, and then you'll be ready to pass the exam. Thank you very much for attending this certification talk. My name is Dwayne Natwick, and I hope to see you again in the future. Thank you very much.